Hello, hello. こんばんは. Think I'm gonna get started. Think it's time. So let me get started. Um, Thank you for watching this. Today I'm gonna create some interesting fractal shape using called Hilbert curve, which I found it by searching on the web. The first time I came into this curve is by watching this video from 3 Blue 1 Brown, which is a famous mathematic YouTube channel, and it's showing several space filling curve, which I find that really interesting, like this kind of triangle shape, filling the space by iteratively increasing its shapes like a fractal shape. And there are many types that fills the space like this. And the most basic shape which fill the space here, which explains in here, is called this Hilbert's space filling curve. And I thought looks pretty easy, so I thought I would give a try to mimic this kind of curve creation together with this kind of interesting tweening animation in using Houdini. So what I did first, I went to this Wikipedia to know a little bit about this algorithm of Hilbert curve, and from what I see, it starts from this kind of basic U shape, then iteratively increases its shape by moving this base U shape to a vertices, each vertex of this U in some angles, some orientations, and connect the end point together to make another shape. Then use that shape as a base shape to the next iterations to map this shape into this U again to create another iterative shape, fractal shape. So then if you increase the iterations, you always have pretty similar shapes iteratively, which looks really like a fractal curve like this. So thought that by looking at this, I thought it's pretty easy, so I gave it a try. And well, the difficult part for this one is that to create how you can create an animation, tweening animation between the previous iterations to the next iterations. And that part I am going to explain in Houdini, which I found the easiest way to do. Maybe there are other ways, but so let me just show you some result that I'm gonna do today. So if I play, it starts from the U shape, then increasingly increases its shape. The density of the shape will increase, then create a fractal shape like this in 2D. So that's for the 2D, but using the same structures or node structures or system, you could also apply this for the 3D version of this Hilbert curve. So let me show you. Let me also show you that. So the base shape for the 3D is looking like this, a bit came from the box shape, unified box shape. Then if I play it, so create a fractal shape based on the same rule which 2D curve had, but became more interesting because it's in 3D and looks more complex. But the rule here is pretty much the same. It's just about changing the orientation on each vertices, how you want to copy the unit curve. So hopefully I could also explain how you can create this 3D shape as well. If you just want to know the result, you just want to see the result, you can also download the file from the description of this video, so you can just go to the that link. It's inside this GitHub called Houdini How to Extra 0018 Hilbert curve. So you can just download this to check this out by yourself. If you know a little bit about Vex, then I think that will be much faster to understand by looking at it. Okay, so let me just start. Create this sketch from scratch by explaining how you could actually make this kind of fractal shape with a tween animation. Okay, let's do that. So I am going to create a new file. What I always do, I'll just change the background to black because it's much easier for me to see. Then create a geometry node and start from the grid, since I just want to have the U shape, so I don't want rows and columns to have too many lines, so keep the rows and columns to 2. Then the size, I will make the size to, well, the size really doesn't matter, so I'll just keep the size to 10. And then I just want to need the polylines, so I am going to use the convert line node to convert this grid into a 4 lines. Then I don't need one of the curve, I don't need one of the line to make it a U curve, so I'll just select one of the curve which I would like to delete. Maybe I will delete, I'll keep this like this, and I'll delete this z negative line, which is placed on the z negative position. So I'll select it and delete it. It will create a blast node automatically. Okay. And next, I will connect all those lines together, because right now I have 3 primitives here. So I want to keep it as one primitive, one continuous primitive, in order to give this point number in an order from the starting point to the end point. So I'll use the polypath to connect all those lines together first, so that I can have one primitive. Okay, now connect the sort node to sort out this point number based on the end position and the starting position of this polyline. So I'll set the point sort to by vertex order, which will make this point number starting from 0, 1, 2, 3, so on. Okay, I will make the text size a bit bigger so that I can see a little bit cleaner. Okay, clearer, right? That looks good. Now let me save this so that I won't lose the file later on. Okay, now while I'm doing this scratch, or how to if you have any questions, you can ask in the chat. I'll try to follow up by looking at it. Okay, now after I have sorted out the point, next thing I would like to do is to again convert this polyline into line. So the reason why I use polypath to connect all those lines together is just to sort the point out. But actually I want the line to be, I want those polyline to be line again. For the later purposes. And let me apply some attributes to this lines to each primitives using maybe attribute create to check like in what iteration it is right now. So I'll just call it ID for a primitive and integer and starting from 0. Since this is the first iterations, so this is the first shape for the fractal base shape. Now after I have applied the ID attribute, I'm also going to apply some group here, which is called group create, which is called div in terms of the division. Now I'll also explain this later how I could use this one. Now the setup, I also need to do one more setup in order to create a fractal shape, is that to set the orientation vectors for each point in order to create a fractal shape. So let me explain in the sketch first what I mean. So say you have this kind of base U shape, and what you want to make is a this. Oops. Let me just change the colors and maybe layers as well. What you want to make is for the next iterations, you want to bring this black U shape into this blue place, a blue area, like a blue curve. So what it's doing here, it's scaling down this black U shape by 50%, then rotate this into the multiplication of 90 degrees. In this case, for this case, counterclockwise. This is clockwise. For this one and this one, no rotations. And the place where it's being copied is on these vertex position of this U shape, base U shape, black U shape. So that's the rule. Pick up this black line, then move the center of this black shape to one of the vertex position, then rotate corresponds to the position of each vertex. So that's what I want to do for each fractal iterations. So that sounds pretty easy. So let me do that. So in order to rotate the shape, move and rotation at the same time, it's what I would always prefer is to use a copy to points or copy stamp node. So I'll use that. I'll explain the method using that node. So that is copy to points or copy to stamp. Copy stamp. Doesn't matter which one you use. Now, so what I want to do first, for each point on this U curve, I want to set the orientation. In this case, if you're using copy node, it will be a normal vector plus up vector to define the up direction. And if you want to also change the scale, then you apply the P scale. So that's the 3 attributes you want to apply to each points. So to make it simple, maybe not simple, but I will use a vex for this purpose. So I'll bring up the point wrangle and I'll just set the attributes to this point from the sort node. Then connect the sort node to the point wrangle. I'll set it to set orientation. And let's see. So for the first point, if the point number is 0, then I would like the normal direction to be facing either horizontally, left side or right side. So let's do that. If pt num equals to 0, maybe there might be a better way to how do I say, set the normal procedurally or mathematically, but I'll just do it kind of manual for this setting the orientation part. Okay, so set the normal to be set -100. Let's check the normal direction. It's a bit too small. Visualize, go to the marker. Where is it? Geometry. Visualize guides, okay. Okay. So for the number 1, I mean the point number 0, it's going left side. So for the number 3 here, if I look at if I check the Wikipedia again or the sketch again, you see that the direction of the number 0.3 is horizontally reverted compared to the 0.01, so I'll just make the normal to be the opposite side on the x direction. So if else, if pt num equals to 3, normal equals to set 100. Right? Sounds good. And for the 1 and 2, number 1 and 2, it will go either upper side or on the downside. I think it goes upper side, so let me also make that conditions. So for that, else, maybe else is just fine because there's only 2 points left. And those 2 points should facing the same direction because it's the same U shape without rotation. So the normal will be maybe something like set 0, 0, 1. How's that? Or maybe it's the opposite side. Maybe it's -1. Yeah. Okay, and also I might need to set up the up direction in order to use the copy node, but I could just try I just I can just try doing an orientation using this setup first. So what I can do is pretty simple. Using this grouped lines, I can just copy this to this point position. And I do see some problems here because the scale is the same, so let's also set the p scale for each point. 2.5 so that it will be half size of the original. And if I look at it, well, looks, if I check with the sketch, the orientation is the opposite side, obviously, so that ain't good. But this is where I can set the up vectors. So what I want to do is that even if you have copied the curve in the right direction like this, the next thing you have to do here is to connect these U shape together with the one line. So I'll write it as green, and what you want to do is after you place the first curve, you have to pick the end curve of the first U curve and the starting point of the second U curve and connect it with the line. And do the same for the other parts to create one continuous next iteration's fractal curve, Hilbert curve. So in order to create this kind of connection curve, the thing is that what you want to keep in mind is that always the point should, each point of the U curve start from 0, 1, 2, 3, and the next one should also starts from 1, 1, 0, 0, 1, 2, 3. If it's the opposite side, if this one starts from 0, 1, 2, 3, then when you want to connect those polyline together from here, the connection might start to this point, then goes like this, then continue creating curve like this. So that's a big problem. So it's not just the orientation, it's just not the direction you want to keep, but it's also, you want to also keep this point number. You also want to check the point number direction as well when you do the orientation. So if I look at the point number, if I turn on the point number like this, so the 0 starting from the right side, which is wrong, obviously. So what if I change this point, the normal direction, to 1, 0, 0? And that is also wrong because the 0 comes to the left bottom side. So what I can do now here is that apply this -1, 0, 0 for the normal again, which looks like this, but then also add a up vector, which goes 0, -1, 0. Then still it doesn't okay, I think I need to, and I think I also need to set up the up vector for other points as well, so let's also do that. Now some part changed, some part didn't, so this one didn't change, so I might need to change some of the value here. This one didn't change. What if I change this to 1? Oops. Okay, now, so by setting the normal to set 1, 0, 0 and plus up vector to 0, minus 1, 0, then you had this U curve starting at 0 from the left top corner and goes to the left bottom corner. So that's the orientation you want for the first point. Now let's go back to the second and third point, curve, which is this setup. So obviously the direction is opposite side, so let's change this to 0, 0, 1. Now it looks good, but still it's wrong, because if I go 0, 1, 2, 3, then the next point you want to have is 4, but it starts from 7 for this one. So what I could do, I can just make the up vectors opposite, so not the negative one, but positive one. Now it seems correct. So 0, 1, 2, 3, 4, 5, 6, 7, and 8, 9, 10, 11. And last, for the point 3, I also need to change some setup. The normal could be the opposite from the point 0, so it could be minus 1. And now it looks good. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that looks good for the composition. In order to add a line in between those separated primitives, it's easy. You can just use add node to connect. Just connect those 4 primitives or 4 curves together, and go to the polygon by group, and it will automatically connect the separated points, separated primitives. Yeah, so that's pretty easy. Right, now that's the first iterations what I have done for the Hilbert curve, and you just need to recursively do the same things over and over again using kind of loop functions to create more complex, more dense space filling Hilbert curve. So that in order to do that, here comes the for each loop in order to control how much iterations you want to have, and I will just choose the for each number for this purpose. And let me change some setups here. First of all, I am going to set the gather method to maybe feed each iterations or merge. Okay, I'll just use the merge iterations, and also for the, or maybe fetch each iterations might be better for the testing without the tweening it, I think. Then for each begin one, I am going to change the method to fetch feedback, so that I can bring up the last created curve like this one for the second input, for the second iterations, for the next iterations as an input to create a more complex one. And that looks good. And I also want to control the number of iterations here using some parameters outside. So I'll create a null node, name it controller, color it, and create some integer value like iterations. Maybe the range is from 0 to, if you make it too big, the calculation never end, so I'll just keep it to something like 6 or 7, maybe 7, right? And keep it to lower number first, because you don't want to crash the PC. And copy this parameter to the iterations. Now you have 3 iterations for this for each loop. And what you want to do, you just want to do the same looping which I have done here, copying this U shape to the vertex U position and connect the gap in between using this add node. And probably you also might want to use the convert line node as well to make it everything a line again. Okay, so you can just copy this inside the node like this, and then for the copy 2 points, for the target points, it's always the same, this U. You always use this as a target in order to copy the basic curve. So you can just connect this to the second, and for the input, I'll start with this one. And if I look at the result, you already have something that you are looking for. So if I change the iterations from 0, 1, 2, 3, 4, 5, 6, 7, you already have this fractal curve, fractal shape, which is called Hilbert curve. Now that was pretty easy. But this is not really what I want to stop here. After making this kind of shape, what I want to do is to create a tween animation from this curve to this curve, and this curve to this curve, and this curve to this curve for each iterations, in order to use the resource of this Houdini have, the rich resource of this Houdini has, since you can programmatically control the animation, procedurally control the animations. So let's do that. In order to do that, in order to create a tween animations, the basic rule is that you have to have a set of curves in order to make a tween in between. So which means in order to create animation between this curve and this curve, the first iterations and the second iterations, then you need to have those both curves already existed in a sketch to make a tween. And if you want to make a tween animation from this curve to this curve, you need to have both curve already exist in the definitions. So that means in order to create a whole tween animations for this Hilbert curve, you kind of have to create every curve, like everything listed here from 0, 1, 2, 3, 4, 5, 6, 7. So using a for each loop with the gather method feedback each iteration doesn't do the job for you, because for each loop it will throw away the last created curve. So by changing this to a merge iterations, you can gather all the information you already had before. But in order to use this merge iterations, you also need to set some attributes in order to preserve the lastly created curve to use it for the next one. So let me do that. Now, if I check the iterations to the second, well, I kind of get whole curve like this by just changing the merge iteration. That looks good. That is kind of what I wanted to have, having all those curve iterations, whole fractal curves on each iterations. But the problem here is that if I look at the geometry spreadsheet for the primitives, I don't have any information like which curve is from which iterations. So that's where I want to use this ID as well as this div group in order to define which curve belongs to which iterations. So after converting the line inside a for each loop, I am going to apply an ID attribute as well as the div attributes using a primitive wrangle. Right, and I am also going to use this for each count as a metadata here. Also, in order to apply a div group, which is used to define which curve should be divided into a lot of points in order to create a tweening, will be coming from this copy node with before filling the gap using add node. And I will name this ID and grouping. Okay, let's write some code here. Go to the a wrangle here, and starting from checking, let me see. What I need to do here is first I need to set the ID here. So I am going to get the iteration number from the detail of from this third input from this one, because if I look at the geometry spreadsheet on detail, I have this attribute called iterations, which means which explains in which iterations you are in right now. 0 means it's on the first loop. 1 means it's in the second loop. So I can use this information in order to set the ID. So int iterations equal to detail from the third input. The attribute name is iteration, right? And I will set the ID for the primitive to this iterations, maybe +1, because the ID 0 is this U shape before you make any fractal shape. So always after you created the first fractal, it always is starting from the ID starts from 1. So if this U shape ID is 0, then the basic fractal shapes generated from the U starting from 1. So and iterations always starts from 0, so I just added 1 to this. Okay, now also the next thing I would like to do is to set the div group to the, let me just set to the simplest form here. Now first I have created this, it's a bit hard to see with the U shape. I will connect the null node in between. Like this. Okay. So after I have copied this U shape to the each vertices of U, a base U shape, and using add node, you are filling the gap in between those 4 U shapes what I want to do is to set a group only to those U curve here, lines which constructs the U shapes here, but not on those filled in gaps part, because that part is not going to be used in, well, it's that part you don't want to divide it into points in order to make a tween, because in order to make a tween in between first point and second point, in this case the first curve and second more complex curve, in order to make a tween in between those curves, you have to have same number of points which construct these curves. And obviously, the points for this curve is much less than the point on the next iteration curves. So you kind of have to increase the number of points for the previous curve, and I am going to do that using resample. And that's how I'm gonna do it. Okay. And in order to divide, the reason why I'm just using those curves without the filling one, well, that's because I don't really know the reason, but that's I tested it on. I realized that I don't need to divide those filling in line to create the same number of points in order to create a tweening. So I just found it out by just trying out myself, like manually. So that's not really like a mathematical answer, but that's how I found it out. So let's do that by just applying those primitives as a div. And the method I am going to use is use a function, vex function called xyz distance. So first, create an empty primitive number, empty primitive integers, as well as empty uv, and calculate the distance using the x, y, z distance function to the second input. So the second input is this one without those filling in curve. And for each center points on this line, for each line here, you have like 15 primitives here. And by using at p, you can get the midpoint of this each primitive. So for the second input, calculate the distance from the center of each lines, including the filling in curve, and also feed some parameters that I have to feed in, which is primitive number and uv. And this primitive number is pretty important because this defines the closest primitive number calculating from the current center of this line, center of each line, including the fillet in curve. Then the rule here, if you search the distance from each center of this line to this curve without the filling in curve, the goal here is to check whether each line is based on original U curve or a filling in curve. And you can check that by checking the distance between the center of each line to the minimum distance to the original U curve. So that's what I'm doing here. So by checking if the distance is less than 0.01, 0.001 or very small, which means it's on the same position, then, and if, maybe I can start with this condition, then I can set the set prim group called div at this prim number to 1. Now, I also want to check if the current primitive that I am going to search is has already have a div group on it. So if not, then I don't want to apply the primitive group to the, even if the distance is really close. So in order to check that, I am going to create use the in_prim group. Check the second input. Check this one. If those U-curve I have a group called div, then that's good. If not, you just want to ignore it. So div at prim, and if distance is less than really small number, and if the indiv is equal to 1, then you can apply whatever line that you find set as a div. Okay, now let's check the output. If I go to the primitive, I have several div group listed here, and I have 3 primitives without the div. And if I check the original one, I can see that the number of filling curves is 1, 2, and 3, so that seems to be correct. And also for the ID, everything is 1 because I only calculated 1 iterations, but if I change the iterations to something like 2 and check the geometry spreadsheet again, I have ID 1 and 2, and that also looks correct. Right, and I am missing one ID, which is the first one when the ID is 0, so I will also merge this to include this very first U shape. Right. Now you have every curves contained in one node. Maybe I'll set the iterations to something 3. Right, so now I have every fractal shapes based on by setting the number of iterations here. So what I want to do next is to pick a first curve and a second curve in order to create a tween animation in between them. So let's do that. And in order to do that, as I explained, you need to have the first curve and the second curve to have the same number of points. So I am going to make that condition using a resample to change number of points for one side, and for the other side you keep the point as it is. So this will be the second curve, and for the left one this will be the first curve. So the first curve to the second curve I want to make a tween animations. So for the first curve, for any first curve, I am going to I have to increase the number of points in order to match with the right one. So connect the resample here, and I am going to set the group to division to where I want to make the resampling to create the number of points. And for the 2D, well, before doing that, let me show you how many points you need to increase. So just picking one of the primitive from the left side. If I'm going to pick the, okay, set, I have to say ID equal to 1. And for the second, let's say I want to pick the ID equals to 2. All right, so let's say I want to make a tween animation from this one to this one. And if I check the number of points for the left side, it says 16. And for the right side, it says 64. So I have to increase like 4 times from the left side to make the same number as the right side. And if I pick the left one to be the second curve and the right one to the third curve, and check the point number again, the left one is 64. The right one will be 256, which is also the multiplication of 4 from the left side. So there seems to be some rules here in between the left one and right one based on the point number. So keep that in mind. I am going to use this resampling and do the resample to the div group and check off this maximum segment length, but I am going to define the number of divisions by the integer number. So for this case, I am going to set it to 5. And if I do that and bring up, if I am showing the ID 3 here, then if I show the ID 2 for the left side, then also let's fuse the point, because by making the resample, you're making a duplicate points on the same position because everything is lying here. If I fuse it and check the number, then the point number is 256, same as this one, more complex curve, but the point number is the same. And if I check the position of the separated points, you can see that the the filling curve are ignored in when you are resampling, but only the U shape is being divided like this. And that, as a result, gives you the same number as the right side. I don't know why this is. I just found it out by myself by trying out many different divisions. So maybe there are some mathematical rule here. You might want to find it by yourself, but I didn't yet. Right? So interesting enough, that's the result. And after the fuse here, I am going to connect all those separated lines, because currently you have like so many primitives, meaning every curve is constructed as a line. So I want to make it as a primitive, I want to make it as a single polyline here in order to, again, make it more lighter. Also set the point order to be starting from the starting point on the poly path to the end in the right order. So use the poly path, connect all those separated lines together. And I also might want to calculate the length, the whole length, but maybe I'll just do it later. For now, it's okay. And after using the polypath, I am going to use the sort to sort out the points based on the curve's UV or U value for each point. So I just set the point sort to by vertex order. Okay. Well, anyone who came here later you can still watch the archive video afterwards, I think. So don't worry about it. Right, so I have make the order of the point based on the curve. It's a bit hard to see here. Okay, now do the same things for the right side. So for these, for the next curve. And I will just delete this delete node and use the poly path. I don't need to fuse this because there's no duplicate points for the right side, I think. And use the same sort node to sort out the point from the start to end. Right. Right, so next thing, what I would like to do is to set what I needed to do. What was I needed to do? So I guess so I want to make animation from starting from the first frame to the end frame to continuously changing the fractal shape from iteration 0 to, in this case, 3. So maybe on the first frame, the iteration starts from the 0, but on the end ends at the iterations 3. So in between, maybe at around 72 or 80, the iterations might be 1, and at around 160, it's the iterations is 2. So I need to calculate this kind of tweening setup here based on the number of frames here. So for the first frame to somewhere around 80, the combinations between the first curve and the second curve will be iteration 0 and iteration 1. But from frame 80 to 160, then the iteration will be from iteration 1 to iteration 2. So that I need to specify procedurally. So let's do that by using a primitive wrangle. Right, and I will say it get1. I'll call it this get1 because this is the left side. For the right side, I'll call it get2. Not the greatest name. So first of all, I need to have the value, the end frame value, so that even if I change the end value like to 360, then you can still have the animation that starts from the first to the last. So in order to get that frame end, I'll make a parameter called chi, something like fend. Since I don't know how to like bring the end frame value using vex expressions, so I'm just using hscript expressions in order to get the fend. So $fend will give you this last frame number here, and by copying this, writing this expression inside this parameter here, the channel here, then I can bring it to the vex like this. Okay, now also I also want to get the number of iterations for this whole fractal shape. And for this number, I can just copy the parameter from the null node, which I have here. Copy this and paste it here. Right, so that I have enough information to create like in which frame you have which set. So let's say int current ID for the left side will be floor or at frame, which will be the current frame, divided by float fend. So this will give you a value from 0 to 1 and multiply it by a number of iterations. So as a result, if this value is from 0 to 1, and by multiplying by number of iterations, then you have the number from 0 to 3 based on the frame position. Right? And since this is integer, I am going to use the floor function to get the floor number. Right. And I just want to pick up the current ID, the same primitive which have the same ID as this current ID from this set of curves here. I have like 4 iteration curves here existed, I think. And from, if the current ID is 1, I just want to pick the curve which have an ID equal to 1. So if current ID is not equal to current primitive ID, then remove that primitive. Okay, something is wrong. This one. Frame num. Okay, everything is gone. Why is that? Okay, current ID. Let me check the number of current ID here. Okay, without removing anything, go to the primitive, and the current ID is 1, 0, 0, 1, 2, 3. So that looks good. That looks correct, since this one is changing. So let's also check if the primitive has an ID. Every ID is 0, so that's wrong. Okay, that is wrong. Need to fix that. Before the polypass, let's check. Okay, before the polypass, I do have those IDs, but applying the polypass, I am losing this ID here, so I kind of need to preserve the ID here, I guess. Now let's go back here. Is there any parameter here? No, I don't think so. Let me check how I did with the one I created before. Okay, sorry for that. Sometimes I forget. Okay, well, it seems like the last one also didn't have the ID left out for this polypass after using the polypass, but there is some rule here. It is that for in each frame the length of the curve is increasing. Obviously, if you look from the first curve, if you're starting from this first curve, so this is the first iterations, and for the second iteration, this looks like this one. And obviously, the length of the curve is increasing. And the third iterations, also the length is increasing. So maybe I can just use the order of this primitive based on the length of these curves, so that the less length you have, the ID is equal to 0, something like that. So I'll use the measure to calculate the length for each primitive parameter, And using in the sort, for the primitive sort, I will use the by attribute and use the parameter to sort out the primitive by the length of each primitive. Now I'll go back to the get, and instead of using I at id, I am going to just use at p prim num. And it looks correct, I think. So if the frame is on the 1, you get the first curve. If I change this frames, then value is changing. The pattern is changing here. Now, I'll do the same things for the right side, but for the right side, I want to have the next iteration pattern. So if I'm getting the curve on this frame, then what you want to have on the same frame for the right side is the next iteration curve, so this one. So for the right side, I also am going to calculate the measure, the parameter here. Then just copy paste this get 1 connected to the right side, and you just want to increase 1 to the as an output, so I'm just going to add 1 to here, and that should do the job, I think. So maybe not this here, but to this one, current ID plus plus 1 is not equal to primitive num, then you'll have the next iterations. So at frame 174, you have this curve, and for the left side, you have one iteration down. Okay, and let's also check the number of points. 256 on the left side, 256 on the right side, and that sounds good. Now, in order to make a tween in between the first curve and the second curve, there's a really handful node in Houdini called blend shapes. So I'm just going to use that because it's easy to use. Just connect all those two curves you want to interpolate, and then go to the parameter called blend one. If you change the sliders, it will change the shape from the left side to the right side like this. Now the result is good, but what you want to do is to control this parameter value procedurally based on where you are at the frame. So let's do that. And that is not that hard. You can just make some expressions to this blend one. And you can do that by doing some similar calculations you did in the primitive wrangle here, where you have calculated the current ID here. So let's go back to the blend and open up the expression editor using Alt E, and let's write some expression here. Now, starting from the current frame divided by the end of the frame, and multiply it by a number of iterations. So let's go back to the controller, copy this iterations and paste it. Okay, I cannot do it here. Let's just accept and go back to the blend shape. I'll just right click, paste relative references here. Okay, and let's go back to the editor again. Now, as a result, it will give you, so this one is a value from 0 to 1, and then you are multiplying with the number of iterations. So based on the frame, the number will change from 0 to 3 in this case. And then, since the blend only works from 0 to 1 in order to create a tween shapes based on the slider position, which is from 0 to 1, what you can do, this one creates a value from 0 to 3, but it's on float value. And last time what I did is dividing it, or just using the floor function in order to create it as an integer. But for this one, I don't need a value upper than 1, but I only need a float numbers here. So just apply the bracket to here and use the modulus and calculate by 1, makes you left with just a float number, which is from 0 to 1. So actually, when the value goes from 0 to 1 to 2 to 3, when it goes upper than 1, then it will just trim out this 1, then starts from 0 again by using this calculation. So I apply, accept. If I look at the value here and change the frame, you see that the value always stays from 0 to 1. And looking at the result, you are also seeing the tweening animation, which smoothly connects from the start to end. And that is the result that I wanted to have. All right. Now, this is pretty much it for the 2D. And in order to visualize it, I am going to do a little bit more tweak. So since this is just a curve right now, and I might want to like express or visualize it using polygon. So I'll just use the polywire to make it to have more thickness. I'll just keep the wire radius as 1, maybe the division to 8. And as you can see, there are tons of points which are unnecessary in order when you are making a wires, especially those points which is on the same line. These points are unnecessary. It just makes the polygon too dense. So I'll just use the refine node to delete those points or dissolve these points. You set the parameter first u to 1, second u to 1, first u to 0, and then check and refine. And as a result, you can trim out those points which is on the same, which sharing the same tangent. All right, makes you more clean. And let's also set the smooth shaded. And let's also increase some iterations, let's say 5. And if I do the animations, slowly, but you can get the animation, the tween animation, like I wanted. Okay, that's cool. That's cool. I think that's cool. Now, so this process was done in 2D, but the same principle can be used in 3D as well, and that is pretty easy to do in this case, in this shape. So let me also explain that, and let's finish this live. Right. So in order to make it as a 3D, I just need to change this initial curve, which in this case U shape, to something more 3D, like a box derived from the box shape, and also setting a value U normal vectors as well as a up vector. you can kind of control, you can kind of get the 3D version of Hilbert curve, procedurally tweening from the first to the end. So let me just do that. I don't want to change this thing because I don't want to lose anything here. I might want to do some mistakes, so I'll just make a copy of this geometry 1 and paste it to, wait, it's not copying. So I just made a copy of this node and turn off the display for the Geo1. I'm getting into the Geo2, and let me just modify a little bit of this current 2D stuff in order to work it, so that it will work for 3D. Right, so first thing, what I would like to do is where's my mouse? Okay, to replace this grid with the box. So give a box. The size could be any size, but this might be too small compared to the grid, so I'll increase the size to something like 5. That seems okay. Maybe 10 is okay. Okay, I'll just go with the 10. The size really doesn't matter, I mean, but just for your shape. Now, okay, I had a question saying, could you use the same process for any geo? Yeah, I do think so. If you look into the YouTube channel, a YouTube called From the 3 Blue 1 Brown, this and the video called Fractal Charm Space Filling Curves, this guy is showing several options, several filling curves pattern here. And obviously, if you can set the right orientation for each vertices instead of the U curve, then I do think it's possible to create your original or your custom space filling curve. So I myself want to try it myself. Maybe you could also do that and show me how you did. That'll be great. That'll be great. All right. So in order to make it as a 3D, let's connect this to convert line, and I need to delete some of the lines in order to create a starting curve for the 3D Hilbert curve. So let's delete, and let's click this select button to select the line which you want to delete. So in this case, this one, this one, this one, this one, this one. All right. Oops. What I did. What did I do here? Okay. Okay, so this is the starting curve that I wanna use, and go through a polypath sort, and come to the set orientations, and there you have. Currently, you have 1, 2, 3, 4, 5, 6, 7, 8 points, and you kind of have to set each point the correct orientation in order to create fractal shape. And that part, I also did this part kind of manually by finding which orientation is good, which orientation is bad. So it's not that smart, but let me do that way. I mean, I already find out the correct orientation, so I'm just gonna show you the right orientation. Right. So first of all, I need to set some conditions here. So if pt num equals to 0, and do the same for the rest of the point number. Oops. So I have 8 points, meaning I have to make 8 conditions, which is not smart, I know. There might be a better, like, mathematical conditions that you can write it in one line, but I couldn't find it out myself. Maybe some of you smart enough could find it out by yourself. So 2, 3, 4, 5, 6, 7, and 8. Right? Yeah, I don't really like this part because it's pretty much manual. I know. 5, 6, and 7. Right. So the first one for the normal, I'll set it to set 1, 0, 0 and up to set 0, 0, 1. Right, let's copy this, paste this, and for the second n 0, 1, 0, and for the up 1, 0, 0. Okay. Well, I wish I could say skip this part, but since this is a live, I cannot. I don't have a magic to do that. Please bear with me. So this one is the same as the first one, I think, right? And copy this. For the third point, for the n 0, 0, minus 1. And for the up 0, minus 1, 0. And the rest of the stuff, since this is a mirrored shape, I think I can just copy this 3 to 4 for the next one. And then also copy these 2 and 1 for the 5 and 6. Use exactly the same stuff, but just changing the up opposite. Right, I think that's fine. And also copy this again. Copy it to 6. Wait, let's... For the 3 and 6, is it the same? Is it the same? I think so. Right, and for the final 7, let's copy from 1. And negative starts from -1. And now let's also visualize the up vectors here using adding the new markers. Up, vectors, up. Okay, so every time you use normal and up at the same time, those two curves always has to be on the 90 degrees or perpendicular. So let's check if this one connects, if this one creates a correct connection by setting to really low iterations. And that seemed to create a line without any weird connections. Let's increase the connect. Okay, that also looks good. Alright, that looks good. Then let's go to the blend shape to check the animations. And something is a bit weird. Yeah, something is a bit weird here. The curves are sliding to something which I am not intended, which I didn't intend it, so something must be wrong here. Let's check the point number here. So starting from 0. This one, 0 here. Okay, that. Okay, I might need to change the orientation a bit to make this tweening a little bit more cleaner. Okay, so wait. Let me go back to the set orientation. I think I need to set either n or up to negative. So I'll try with setting n to negative. So for this one, negative, this one negative, this one negative, this one positive, this one positive, this one negative, this one negative, this one positive, and how's that? Right, let's check again the final result. Okay, the result is bad, so that's not good. That is not good. Let's go back. Okay, so what about changing the up vectors to negative? Oops. Well, what I'm doing here is just tweaking, so it's not really my intention. I just wanted to tell you that making from 2D to 3D is pretty simple, as I show here. Okay, this is also bad. Right, then let me go back again. Okay. Well, what about changing this size to -1 to change the orientation here? Okay, it's bad. Okay, let me just check the original one, which I have already created before, and see the difference here. Now, which is kind of cheating, but doesn't matter. Right. So I guess the original curve setup is a bit different than I made here. So let me just go back to where I have deleted the lines. This one. And check this angle again and set new lines which I want to delete. So this one, this one, this one, this one. That's it. Probably. Nope. I need to delete this one as well. So add another one here. Right. So how's this? So go back. No weird connections. And if I do the animations, how does it goes? It still does creates a weird. Okay, I know the reason here. The reason why I'm getting the weird animation like this one, because the number of points here in left side and the right side is different now. So if I look at the left side, it's number 36. So on the right side, it's 64. So the 2D version, I divided the curve with the group div using a 5 using resample. But for the 3D version, I have to increase the number of divisions, the segments here, to 10. So if I make it to 10, then the point on the left side, 71, 60, okay, that's not good. Maybe 9. Was it 9? Let's check. 64, 64, and if I change the frame, 112 on the left side, 112 on the right side. Okay, so also this number of resampling, I found it manually, so I don't know exactly how you can find it mathematically, but there must be a rule here, obviously. So I hope you could. I would like to find it myself as well, but you please try to find it by yourself as well, which could be really interesting. Right, then let's go back to the animations and check. Okay, now that looks good. That looks good. Making a tween animation from the left side to the right side. Smoothly connects from the first to the last one. And let's increase the iterations. For the 3D, as you can imagine, increasing the number of iterations gives you tons of calculations, so don't make it too big. Maybe 5 is maximum for my computer. And as you can see, it's pretty slow. It's the initial calculation, so after you have it calculated, the tweening part is much faster because you already have the sets. Okay, still calculating. Okay, wow, it's a lot of points, a lot of curves. Maybe 4 is maximum for myself, for my computer. If you have tons of CPU, you might be able to go from 5 or 6. Maybe don't go to 7. Okay, still calculating something, right? Let's do some animation from here. Growing. Yeah, like it. Like the result. Right. And by making a polygon, you could also send it to render as a 3D. Or maybe send it to like 3D printing to physically print it out for your toy. Okay, so that's about it for this live. I think I am not going to explain about the coloring because it's pretty simple. You can check out the definition. You can download the files that I have provided, and you can download from the descriptions to check how you can set the color based on the point position on the curve, which is not that hard. You can just check. You can just get the point number as well as the total number of points for each primitive, and use that value to feed with a color node. Okay, so that's it. Thank you very much for watching. If you have any questions, please ask. If you don't, then I would like to finish at this point. hope you enjoyed it. I mean, I myself find this curve creating method interesting. I hope some might find it also interested. And I would definitely want to try this out with the different types of shapes. Not just this square type, but like triangles or hexagon or more complex shape. Maybe into 3D as well. Okay. Okay, that's it. If you don't have any questions, I would like to finish at this point. Thank you for people who continued watching this. And sorry for my English. This is not my native. Okay, thank you for the comment as well. And I think I'll do the live again next week. Probably next week will be in Japanese. But I mean, based on the number of comments, I guess maybe I will change it to English as well. I don't know how many Japanese people would wanna watch this kind of stuff. Right. Thank you and goodbye.